So many of the whistles we repair have special meaning to their owners. They're not just a chunk of brass that makes noise. They're a memory of a time gone by. To be part of recapturing the memories is a cherished part of our work. This is a story of how a small repair, a wildfire, and a childhood memory turned a simple project into a labor of love. The shop foreman at the Roaring Camp and Big Trees Railroad in Felton, California, asked us if we could repair a crack in a single chime whistle as a gift for the owner of the railroad, Melanie Clark. The whistle had special meaning to her since her father, who had started the railroad, had put it on the engine when he purchased it in 1962. The whistle had been damaged at some point and was unusable for the last 20 years. My family made many trips to Roaring Camp when I was young to ride the steam engines up the steep grades and to hear the whistles. The day after the whistle arrived in our shop, the CZU Lightning Complex fire began. Within a few days of the start of the fire, the Roaring Camp and Big Trees Railroad was threatened. Luckily, the railroad was spared. The whistle was shipped to our shop, and it was immediately apparent that the crack was only one of the issues that would prevent this whistle from being put back into service. The whistle had seen a lot of use, and somewhere along its life it had been slightly bent so the steam admission slit was no longer concentric with the bowl. The poppet valve stem had been excessively worn, and the valve guide was egg-shaped. The valve seat was grooved beyond repair, and the fulcrum pivot points were severely damaged. The center support was corroded to the point that the threads were missing on a good portion of the shaft. And the main reason they asked us to help with the repair, the casting that made up the cap was cracked 3/4 of the way around the center support. The cap was beyond reasonable repair, so the decision was made to make a pattern and have a new cap cast. This would allow us to increase the weakest point of the whistle from 1/8 of an inch to 3/8 of an inch thick, and hopefully stop any further cracking. While the cap was at the foundry being cast, we started in on the valve body by boring out the valve stem guide and installing a pressed-in bushing to bring the hole back to a standard dimension. Once we had the bushing installed, a new poppet valve was machined from bar stock. A piece of steel was added to the end of the stem to help reduce damage from the fulcrum arm when the whistle was blown. A new fulcrum arm was drawn up and sent out to be laser cut, and the fulcrum pivot points were bored out and new bushings were made. The next step in the repair was to chuck up the bowl and to see if anything was running out of round. As it turned out, this is where the damage was really concentrated. The bowl in the center casting that forms the inside steam admission slit was bent and deformed. The two parts must be concentric if the whistle is to sound correctly. We first machined the inside of the bowl to get it cleaned up and running true. Then we set up and faced off the center casting, removing the deformed hub and making sure the face was running true to the mating part. Once the face was flat, we cut the outside diameter down by 1/4 of an inch and created a step profile. A ring was machined out of brass with an interference fit and then heated and pressed on to the center casting. Once the two were mated, the ring was silver soldered into place. The center casting could now be machined to finish size and bring the steam admission slit back into tolerance. The next step after the bowl was the center support. A new steel support was made and a large hex machined at the bottom to help take the place of the hub that was machined off earlier. The threads were left long enough to add a stainless steel nut on the bottom of the casting to prevent excessive stress on the brass threads. The spider or center support keeps the bell from moving from side to side when the whistle is blown. The excessive pressure had allowed the spider to move up on one side and vibrate, causing the mounting hole to become out of round. We bored out the hole as large as we could, and then we made a bushing with a shoulder to press into the part. Once it was installed, the new bushing was soldered into place. 2 set screws were drilled and tapped to help secure it to the center support, and we added 2 small flats on the center support for the set screws to tighten against. The the last step in the process was to machine the new cap. The casting was chucked up in the lathe and machined to match the original. Then the bell and cap were pressed together and soldered. The entire whistle was polished, and then it was off to Roaring Camp to return the whistle and test it on steam. The whistle cord was pulled on the Tuolumne for the first time, and the sound that hadn't been heard for years was once again echoing in the hills. It was an honor to work on one of the pioneers of the tourist railroad industry and to help bring back a memory of a great father.